Hey math kids, today we're going to talk about coordinates in proof, and I think we're going to start with a review real quick. So if we we have our y-axis, x-axis, we have a line segment, and if we want to find the midpoint, we use something called the midpoint formula. And so if this is x1, y1, and this is x2, y2, we just say x2 plus x1 over 2, and then y2, y1 over 2. Okay, hopefully that's a review. That's just the midpoint formula. Now, today, we're going to do something. What if we don't want the midpoint? What if we want a point like right here? What we do to modify that situation is we do something that's kind of like the midpoint formula. So we have this, we have point P, which doesn't have to be the midpoint. Let's change colors. So we're going to call this P, and it's x comma y. We're still going to call this one x1, y1. We're still going to call this x2, y2. So we still need the endpoints. But then we're going to think of a ratio right here. So we want to know like how big that segment is. We want to know how big this segment is compared to this segment. And that's what these M1 and M2s are going to do. And so the midpoint formula becomes that, okay? And if you just follow the same steps as you would with the midpoint formula, it's really not that bad. It just has a little bit more to it, and this is just kind of, hopefully you can see the similarities between it, something added over the same thing. It's really just like a special type of average, because if you notice in the midpoint formula up here, we're just adding the x's and then dividing by 2, or we're just finding the average of the x's and the average of the y's. But this is like a weighted average, where this is going to play a bigger role than this because it's bigger. Does that kind of make sense? Hopefully. So we're going to use this. We're going to do a problem. So it says 2 endpoints of the line segment are 4, 1 and 3, 6. What point will split the line segment into a ratio of 4 to 1? So that the point lies 4 times closer to 4, 1. So we're closer to 4, 1. So if we're drawing this, now the cool thing about this is our diagram doesn't have to necessarily match up. Okay, so we want to be closer to 4, 1. So this is going to be 4, 1. This is going to be our xy that we're trying to find. This is going to be 3, 6. And so this is going to be 1, like our m1 is equal to 1, and our m2 is equal to 4. Once again, it needs to be 4 times closer to this one. Now, even though this diagram doesn't really make sense with how I did it, because 4 would be more over here than 3, it doesn't really matter, okay? So I'm just going to plug it in here. I just need to make sure I know my 1 is my m1, and that this is my x1, y1, x2, y2. So now I got to plug it in here. So m2 is the first thing I do. So it's a 4. Then I times that by x1, which is also 4. Then I add m1, which is 1. x2, which is 3. And that's all divided by m1, 1 plus 4. Okay. And then I go to M2, Y1. So M2 is 4. Y1 is 1. And then M1 is 1. Y2 is 6. And that's over 1 plus 4 as well. Alright. Now it just comes down to simplification. So this is 16. This is 3. This is 5. So 16 plus 3 is 19. So we get 19 fifths. 4 times 1 is 4. 1 times 6 is 6. That's 5. Add those together. We get 10 over 5. So this is where the point needs to be, right there. So this x comma y value is 19 fifths comma 10 fifths. Alright, hopefully that wasn't too bad. I'm going to copy and paste this formula so we can see it down here. Alright, can't move it, whatever, that's fine. Okay, so let's try one more. So this time we have, let's see, there we go. Okay, so we have A, which is 4, 2, B, which is 6, negative 5, and then we have point C, which we don't know, but we know AC and CB are in 3 to 1. So AC, CB is 3 to 1. And then we want to find C. Okay, once again, draw a diagram. It doesn't really matter. So if we call this, let's see, CB is shorter, so A, B, C. This is the shorter one, so this is going to be our 1. And this is going to be our 3. Okay, B is at 6, negative 5. This is 4, 2. Then we want to know x, y, which is right there. Okay, now we just plug this in. So this is our M1, M2, X1, not X2, X1, Y2, X1, Y1, X2, Y2. Alright, so we have M2. Let's use a different color. So M2 is 3, and then we times that by X1, which is 6, and then M1 is 1, X2 is 4. That's all divided by 1 plus 3. Okay, move that over. M2, Y1, so that's 3 times negative 5 plus 1 times 2. That's all over 1 plus 3. Alright. Okay, that's 18. That's 4. That's 4. Add those together, we get 22 over 4. We'll simplify that in a second. This is negative 15. This is 2. And this is 4. So that's going to be negative 13 fourths. Whoops. And then if we can simplify, we want to go further. So 22 divided by 4 is going to be 11 halves and negative 13 fourths. And so that's going to be the final answer for this point C. Okay, I think that's all we need to talk about on this one. Yeah, if you need additional help, please come to Math Lab. Until then, count you later.